Hey guys, so I just wanted to quickly do a little bit of a review on the drawing schematic diagrams practice worksheet that you did last week as an assignment. Some of you guys did an awesome job with this. I do completely recognize that this is tricky and this can be confusing, and it's a lot of your first times drawing schematic diagrams and drawing circuits in general. So it's totally okay. Just wanted to go through some of the exercises so we're all on the same page here. So I'm going to skip numbers 1 and 2 on the worksheet just because they're pretty self-explanatory, and I pretty much showed you how to do those during last week's Ed puzzle. So we're going to start off with number 3. And for this question, it says draw a circuit diagram containing one battery, one switch, and 3 LEDs wired in parallel, where the switch controls all 3 LEDs. So I always like to start off with my battery first. And I did notice on when looking at some of your worksheets that a lot of you guys are drawing the battery upside down. I always draw the battery with the long side or the positive side on top and the negative side on the bottom, and I draw it vertically. If you stick kind of with one method and keep that consistent throughout all your schematic diagrams, it's going to make your life a lot easier. So we have the battery. I'll just label that with 9 volts. You don't have to put the positive and negative symbols there. I'm just putting that there so you can kind of understand that. So now it's saying we need one switch and 3 LEDs wired in parallel, where the switch controls all 3 LEDs. So I'm actually first going to just draw my 3 LEDs wired in parallel. And again, you'll notice that I'm drawing the LEDs in a specific orientation. You always want the arrowhead of the LED to be pointing in the direction of current flow within a circuit. So in this circuit, current is flowing from positive to negative, and we have current flowing down, and then current flowing back to the negative side of the battery. So it just kind of helps you remember always the LED arrow should be pointing in the direction of current. In this case, current's going down in this circuit, so the LED should be down. So these 3 LEDs are wired in parallel. Now I just need to add one switch that allows me to control all 3 LEDs. This switch can kind of go in I would say one of 2 places. You can decide to put the switch here up at the top. And I would always draw your switches open. It's just a lot easier to see. If you draw your switch closed and you don't make these dots, these nodes large enough, it kind of looks like it's just a wire. And you kind of do want to avoid that. So my switch is open. If I use my pencil to follow the flow of current, if this switch is closed, then current can flow here and go down to LED 1, down to LED 2, and down to LED 3. If my switch was here at the bottom instead of up at the top, that would mean the same thing. I could go from the positive side of the battery down through all 3 LEDs and come around, and my LEDs would work. I'm going to keep mine on the top for now. Again, either one's technically correct. So I just want a wire there. Now, if this switch is open and I use my pencil to follow the flow of current, there's a break here, so the circuit's broken, so then I cannot go to any of the LEDs. So it's controlling all 3 LEDs there. So that's number 3. Let's take a look at number 4. So it says to draw a circuit diagram containing one battery, one switch, and 3 LEDs wired in parallel, where the switch controls LED number 2 and LED number 3 only. So we're going to start off the same with our 9-volt battery. I always have the positive side on top. And for numbers 3 and 4, I don't think I had you label anything, so I'm just adding labels here for fun, I guess. my 3 LEDs are going to be wired in parallel again. And now I need to add a switch that controls only LED number 2 and LED number 3. So there's really, again, kind of 2 places where you can put that switch. You can put it here up at the top, or directly opposite down at the bottom. And again, if I follow the path of current, it looks like this LED will always be on because there's no switch controlling it. This wire here branches off into this node and this node that is wired with LED 2 and LED 3. So this switch only controls those 2 LEDs. All right, moving on to number 5. In number 5, you're drawing a circuit diagram containing a 9-volt battery, a 220 ohm resistor, and an LED controlled by a switch wired in series. So this is a simple circuit, just your basic simple circuit, probably the simplest you can get. It does not matter necessarily the order in which you draw these, but when you do start building circuits, the order does matter. I always just like to get in the habit of putting my resistor in front of my LED because that is resisting a certain amount of the current that flows through the LED. If you don't have a resistor in a circuit with an LED, a lot of the times in real life the LED can kind of blow up or burst and you're not going to be able to use it anymore. So I just always get into the habit of putting this resistor before the LED. The switch really doesn't matter in which order or where you wire up that switch. So for this, for numbers 5 through 10, I had you label some things. So what I expect in terms of labeling, if you know the voltage of the battery, label the voltage of the battery. If you only have one resistor, and you know the resistance, just put the value of the resistor next to the picture of the resistor. You don't need to write R1, you don't need to write resistor, that's fine. If you have multiple switches, you do want to label them like S1 or S2. So if you want to get into the habit of just doing that now, you can do that. And then the same thing with the LED. If you have multiple LEDs, you can name it LED 1, LED 2, LED 3. So it's nice to get into the habit of that. And then the last thing you have to show is the flow of current. Okay, and you don't need to add a ton of arrows. As long as you have a good amount of arrows, you should be pretty good to go. So that's number 5. Number 6. Draw a circuit diagram containing a 9-volt battery, 2 220 ohm resistors, and 2 LEDs, each controlled by switches wired in parallel. So I always start with my battery again. We have a 9-volt battery. And then we have 2 resistors, 2 LEDs, each controlled by switches wired in parallel. So the easiest way to do this, really, since you know everything's being wired in parallel, is to just put each kind of set of components on its own strand in the parallel circuit. So we have my first strand of our parallel circuit, my second strand, and now we're good. So each of these LEDs are controlled by their own switch. Even if this LED is on, switch is closed and this one is open, this system will still work. If the opposite was true and this switch was closed and this one was open, this strand or this LED would still work. So you're good there. I would label this S1, R1, and then LED 1. Then we have S2, R2, LED 2. And then the only thing you really have to show off on the side is the value of the 2 resistors. And we know in the question that they were 220 ohms. All right, let's go on to number 7. Draw a circuit diagram containing a 9-volt battery and 2 LEDs wired in parallel, where both LEDs are controlled by a 10 kilo ohm potentiometer. So this is the first time we're introducing the new circuit, the new symbol, which is a potentiometer. So again, I always start off with my battery, and I didn't do a good job of showing the difference of those lines there, labeling it as 9 volts. And then I have one potentiometer controlling 2 LEDs wired in parallel. So I know that if I want the potentiometer to control both LEDs, I have to have it or position it before I create kind of my 2 strands for the 2 parallel LEDs. So this potentiometer controls LED 1 and LED 2. Potentiometer, label it P1. Then we have LED 1 and LED 2. We know that the value of this potentiometer, or the max value of this potentiometer, is 10 kilo ohms. And then we can just show the flow of current. Again, you don't have to go crazy with the arrows. Let me get a new sheet of paper here so I can do the rest. Actually, I'll just do it on the back. This is perfect. Okay, let's do number 8. So, in number 8, it says draw a circuit diagram containing a 9-volt battery and 2 LEDs wired in series and 1 LED wired in parallel, where all 3 LEDs are controlled by switches. And I gave you a hint that you should only use 2 switches. So I'm going to start again just with the LEDs and the battery. So I have my battery, 9 volts, and now I have 2 LEDs wired in series. So that means they have to be kind of on the same wire here. And then I have a second LED wired parallel to those first 2. And now, let's see, all 3 LEDs are controlled by switches. So I need 1 switch to control just that strand of LEDs. And I know I'm kind of drawing small here, but I'm doing my best. And then I need a second switch to control just this last LED, because you want these 2 systems to be independent of each other. So if this switch is closed, but this is open, these 2 LEDs will still work. If this switch is closed and this one's open, then LED number 3 would continue to work. So they're independent of each other. If I put the switch here, then this switch would control all 3 LEDs, and we don't want that. We want them to have independent systems. Same thing if I put the switch on the bottom here. It would control all 3 LEDs, but we did want independent systems. So we have switch 1, switch 2, LED 1, LED 2, LED 3, no values, and then we have the direction of current flow. Okay, moving on to number 9. A 9-volt battery is powering 1 LED controlled by 2 different switches. The light bulb is on if either of the switches are on, which are closed. So it's kind of confusing because a closed switch means on. You would think it means off, but it's kind of opposite. So I'm going to start with the battery. And now it's powering 1 LED controlled by 2 different switches, and the light bulb must be on if either of the switches are closed. So I'm actually going to put a switch here, and I'll explain why in a second. And then I'm going to wire up another switch parallel. I'm going to draw these lines a little bit longer. And then both of those switches are going to connect to an LED. All right, so let's kind of take a look at this, and I'll do my best to explain why I decided to draw it this way. So we have the first switch and the second switch. If this switch is closed, but this switch is open, the LED will work. Now let's see the opposite. If this switch is closed and this one is open, the LED will still work. So it asked you to make a circuit where if either of these switches are on, so if switch 1 is on, the LED would work. If switch 2 is on, the LED would work. So we created like 2 independent systems. Again, a lot of the times you will use parallel circuits when you're needing to do things independently. Switch 1, switch 2, and LED 1. So that's number 9. And then last but not least, we have number 10. So in number 10, a 9-volt battery is powering one LED controlled by 2 different switches. The light bulb is on only if both switches are closed. So this one can be kind of confusing, but it's actually more simple than you think. I always start with the 9-volt battery. And then since it doesn't seem in the question like I have any independent systems that need to be happening, that should give you a clue that you should wire the 3 components in series. So now since there's only one loop here, only one path for current to flow, both of these switches need to be closed in order for this LED to turn on. If either of these switches are open, so say this switch 1 is closed and this one's still open, LED won't work. Both of them need to be closed in order for the LED to work, and that's what it asks you to kind of figure out in the question. So let's do switch 1, switch 2, LED 1, show the flow of current, and we're good to go.